I ran into an issue where I couldn't reduce it anymore. And so we ended up with, I think, with then 5 equations, 5 unknowns. There was something else funky. Maybe that was missing, that was over here. I forget exactly where the mistake is. So you can take through the first method for the lab, no problem at all. You can do this for the lab, use the Kirchhoff equations to come up with your 8 equations, 7 equations, 7 unknowns. And that works too. All right, questions before we look at a simpler one? Simpler in the respect that it'll be 3 equations, 3 unknowns. All right, let's do it. On test 1B, the next test that you take for me. The last question on the test will be something very similar to what I'm about to show to you. I'm telling you that now. The batteries I may flip the batteries directions and the numbers will change, but this is the essence of what that last problem is going to be. Put a battery here, a resistor, a battery, a resistor, and let's have that facing upwards. Battery. 2 volts, 4 volts, 6 volts, 1 ohm, 2 ohms, 3 ohms, 4 ohms. Wait, sorry, I don't want to repeat numbers here. So let's make, I'm going to keep 3. Get rid of that, and that. Sure, just change. So keep that at 6 volts. My resistors, let's do 3, 5, 7, and 9. And the question will be, what is the current flowing across each resistor, and what is the potential drop across, and then, or potential difference across, and then I'll pick one of the resistors. Typically it's either that one or that one, but it just depends. So you'll see a display. I3, I5, I7, I9, and delta V7. Value, direction. These are not vectors, even though there's a magnitude and a direction. We're not dealing with vectors. All right. There are 2 methods for solving this. The first method is what we did in the more complex version of this. For each path, I have 2 junctions here. I have a junction here and a junction here. I have 3 ways from getting from one junction to the other. And so for each of those pathways, I am going to make up a value for a current. Those are my unknowns. So for my right side here, I'm just going to call this, since A gets confused with amperes, I'm just going to start out with B. For this pathway over here, I'm going to choose C, and for the middle, I'm going to choose D. It does not matter if I pick the correct direction. Matter of fact, I'm willing to bet that C is in the wrong direction, but I don't know. Maybe it is. I suspect C and D are both, I think probably have all 3 in the wrong direction, but we'll find out. So first thing I do is I assign for each pathway between junctions, I assign a current. Next, I need to come up with 3 equations. Got 3 unknowns, I need 3 equations. My first equation, or the first one we're going to do, is the junction rule. Current in equals current out. So what would my first equation be? Someone take a shot. Worst that happens is you're wrong.
D plus B equals C.
Say it again.
D plus B equals C.
All right, so B plus D equals C. All right? Because at this junction, those B and D are going in, C is coming out. Or at this junction, C is coming in, B and D are going out. My next equation is, my next 2 equations will be using the voltage rule. And given my basic setup here, I have a loop on the left side, loop on the right side, and I have the entire thing. Those are basically my 3 simplest choices. They are not independent. If I do 2 of them, I can derive the third, so I only need 2 of the loops. And it doesn't matter which 2 you pick. You could get into some really funky shapes if you want to do a figure 8, that's fine, but waste of time. I'm going to take the left loop. Now, again, childhood scars, I like the first number in my equation to be positive. So I'm going to start here. I'm going to start here. Sure, whatever color you want to give me. And I'm going to go around clockwise. So first thing I do is I go across the 2-volt power supply. Now I'm cruising across my 5 ohm resistor there. I'm going with the current that I assigned B, so it's minus 5B. This is just Ohm's law. This is current times resistance. I'm now cruising down the center here. I'm going against the current across the 9 ohm resistor, so it's plus 9D. I go across the 4-volt power supply here, and I'm going in the direction from negative to positive, so plus 4, and then down to the 7, minus 7B equals 0. Take a moment to make sure you understand how I got those, and ask questions if you don't. The next loop. I'm just going to do the whole thing. Just go around the outside. I'm still going to start at the 2 and work my way around. So I start at 2. I go across the 5 in the direction of the current, so minus 5V. I go across the 3 ohm resistor in the direction of C, so minus 3C. I now get to this power supply, and I'm coming down at this point. So I'm going from the positive to the negative, minus 6. And then I get around to here, I'm going across the 7 ohm resistor in the direction of B, so minus 7B equals 0. If I subtracted these 2 equations, as is, this is a side note, if I subtracted the 2 equations, 2's cancel out, the 5B's cancel out, the 7B's cancel out, what I end up with is 9D plus 4 plus 3C plus 6 equals 0. Well, that is 10 plus 9D plus 3C equals 0. That is my right loop. If I started here and went counterclockwise, I get 6. I'm going against the current, so plus 3C. I'm going against the current, plus 9D. Going with the negative to positive on the battery, plus 4 equals 0, and that's what I have right here. So that third equation is not independent of the first two. But here, 3 equations, 3 unknowns. If you're going to solve simultaneously, well, I still recommend it. If you're doing substitution, you don't really have to change the order around, but I'm going to, because usually it's the monk in me. Adrian monk, that is. So my first equation, I have B minus C plus D equals 0. My second equation, I've got, let's see, what are my B's? I have negative 12B so negative 12B minus 9, or plus 9D equals, I've got 6 on the right-hand side here, and I take it over negative 6. I wonder if there's an umbrella in my office. I guess I'll find out. And then the last equation, I got minus 12B minus 3C equals, I've got negative 4 on the left-hand side, so I take it over at 4. Next step. What method we can use to solve it? So Cramer's rule. Any of you know what I mean when I say Cramer's rule? Probably not a good audience to do my Seinfeld reference here, so we'll skip that. All right, determinants. First thing let's just do a side note here on determinants. If I've got 1, 2, 3, 4, and I'm finding the determinant, there are many ways to do determinants. What I'm going to do is I'm going to start in the upper left-hand corner, and I recommend you do the same, but you can really start anywhere, but that just gets way complicated if we do it that way. Start in the upper right-hand corner, I write that number down, and then I cross out that row and column, and what I'm left with, I do a determinant of what I'm left with. Minus, because as you go across, you alternate signs. 2 is the next one. I will eliminate that row and column, and what I'm left with is a 3. And so this determinant of 4 is 4, so this becomes 4 minus 6, or negative 2. That is the determinant of this 2 by 2 array. Ringing bells? Yes, yes, and sort of, and okay. If I have a 3 by 3, we will go back to this. That one. If I have a 3 by 3, so 2, 1, negative 1, 4, 7, 8, negative 3, 5, and 0. The determinant of this is, I start in the upper left-hand corner, 2 times, mark out that row and column, and what I'm left with is there's a negative 1 there. What I'm left with is 7, 8, 5, and 0 equals. Minus, I go to the next one, 1 times. Eliminate that row and column, I'm left with 4, 8, negative 3, 0. Plus, I go to the next one, negative 1 times, cross out that row and column, 4, 7, negative 3, 5. Now, if I have a 2 by 2, I'm going to find the determinant of a 2 by 2 array, look what would happen here. Ultimately, it was just this diagonal minus that diagonal. So 1 times 4 minus 2 times 3. So I can do the same thing over here. I have 2 of 0 minus 40 minus 1 times 0 minus negative 24 minus 1 times 20 minus negative 21. So I get negative 80 minus 24 minus 41. Doing the fancy math, I get 5, 4, negative 145. Okay. All right. Questions on that? Notice I get the same answer. 2, 1, negative 1, 4, 7, 8, negative 3, 5, 0. If I just repeat those first two columns, 1, 7, 5, and then I multiply that diagonal, I get 0. That diagonal, minus 24. And then that diagonal, negative 20, minus that diagonal, which is 21, that diagonal, which is 80, and that diagonal, which is 0. I end up with negative 44 minus 101, which is negative 145. So if I have a 3 by 3 determinant, some might consider that a shortcut. 2 by 2 is just across, 3 by 3, you got three slashes, 3 slashes. Before the widespread use of calculators, I worked with a woman who, when she taught doing determinants, the test was a 4 by 4, and that was it. All right, let's actually apply Cramer's rule here. Cramer's rule, if I want to solve for b, I'm going to set up a fraction here. My denominator is just the coefficients of my numbers here. So I have 1, negative 1, 1, negative 12, 0, 9, negative 12, negative 3, 0. So with denominator, matter of fact, when I solve for b and c, the denominator is the same. So once I do this determinant, I don't have to do it again. And that is going to be, well, let's do the repeated method. 12, then negative 1, 0, negative 3. I multiply that diagonal, 0. That diagonal, 108. That diagonal, plus 36. Minus this diagonal, 0. That diagonal, negative 27. And that diagonal, which is 12. So I get 144 minus negative 15, so 159. Unless I've made a careless error, which at some point I probably will. All right, the numerator is going to look similar to, but obviously it can't be the same. We haven't taken the constants into account. So if I'm solving for the first variable, the b's, then I'm going to replace that column from the denominator. The other two rows are the same. So I got negative 1, 0, negative 3, 1, 9, 0. My first column will be those. So 0, negative 6, and 4. And I do my 3 by 3 there. I get 0 plus negative 1, 9, 4, negative 36. And then 1 times negative 6 times negative 3, which is 1 times negative 18, plus positive 18. Minus, going the other direction, I got 0, 0, and 0. And so this ends up being negative 18. So my current, that is flowing across somewhere. So B here, the current flowing across A and the 5 and the 7 ohm resistors and coming out of the 2 volt battery right there is negative 18 1/59ths. So over here in my chart, the current flowing across the 5 ohm resistor. I can write it 2 different ways. I can keep with the direction I have, so going that direction, negative 18 1/59ths. Or, the negative means it's going in the other direction. I could, if I wanted to, put the arrow in this direction and make it positive 18 1/59ths of amperes. So let's not forget units. Don't put both, put one or the other. And then across the 7 ohm, it is, so going that way, so 18 1/59ths amperes going to the right. Is it right? I don't know. We'll check it in the end. All right, questions up to here? Oh, class ended 7 minutes ago. We'll do something similar to B and for C, and then we will then pop it into the first equation to see if it makes sense. And if not, again, we have a decision to make of how much time we're going to spend trying to figure out where the mistake is. I did in 152, I was doing something similar, and I we realized that there was a mistake, and then spent 10 minutes trying to figure out where I had left the minus sign off of one number. And that threw everything off.